We are now going to go through an example of using these derivative shortcut formulas. So let's take a look at example 1 in our 2.1, 2.2 notes. So we're given, let y equals x cubed plus x plus 2 plus 3 to the x plus 1 over x squared. Find y prime. So in order to do this, we first want to write the function in a form so that we can recognize each term as a function we can compute a derivative of. So what I mean by that is if we look at our terms, we have x cubed. We've seen that function before. We're going to use a power rule. Now just x, we haven't seen the function just x in our previous shortcuts. However, the function x is equivalent to x to the power of 1. We have an imaginary 1 in the exponent. So I can write this function or this term as x to the 1 in order to recognize how I want to compute the derivative of it. And now continuing on to 3 to the x we've seen before, but what about 1 over x squared? Can we write it in a way to recognize how we could compute the derivative of it? Well, certainly we have x in the base and a 2 in the exponent, but it's in the denominator. So what we can do to change that location of x squared is to rewrite it as a negative exponent. So this is just using exponent properties. 1 over x squared is equivalent to x to the negative 2. So let's go ahead and rewrite y in a way that we can compute the derivative of each term. So I'm going to say rewrite y as y equals x cubed plus x to the 1 plus 2 plus 3x plus x to the negative 2. So now each term that I've written here has a shortcut formula for its derivative. So what I'd like you to do is pause the video and work through each term in this sum and compute the derivative of each term. When you're ready, continue the video and we'll work through it together. So given this y, then y prime, the derivative, is going to be equal to, so this first term we use the power rule, 3x squared. The next term we use the power rule again, so the 1 comes down, x to the power of 1 minus 1, and we'll see what happens there in a bit, plus derivative of 2 is just a constant, so that's 0, plus derivative of 3 to the x, we use that exponential function rule. So we have 3 to the x times ln of 3. Plus, here we have another power function. So the negative 2 comes down, and we subtract 1 from the exponent. Nice. So let's clean this up a little bit. So here we can combine that 1 minus 1 to be 0. So this is 1 times x to the 0. And recall any number to the 0 power is just 1. So this is just 1 times 1, i.e. 1. And then here, let's see how this exponent cleans up. So we have a negative 2 times x, negative 2 to the negative 2 minus 1 gives us negative 3. So I can move that base to the denominator to get negative 2 over x to the 3. So this becomes, after we've cleaned it up there, y prime is equal to 3x squared plus 1, the 0 we don't need to rewrite, plus 3x times ln of 3 minus 2 over x cubed. So this would be our final answer. All right, great work, everyone. Feel free to rewatch the video going over the derivatives of each of these terms. We have a few more examples that we're going to work through together.